The first 3 weeks of the eruption here in Hawaii, crazy things would happen in the middle of the night. A new fissure would open up and it would threaten a new neighborhood. Thousands of people were evacuated from their homes. I started the Hawaii Tracker Facebook group to help people understand what's going on and get their questions answered.
Hey, how's it going? We're live. This is Fissure 20.
We had hundreds of people all throughout the neighborhoods sending in videos, articles, and images. We spend a lot of time making sure the accurate information gets out.
This is live. There's still lava moving.
They weren't just sharing a story, they were helping their neighbor. If a family was being evacuated, the group would just jump in and help out. So it was huge. They were watching out for each other.
Hello everybody, thank you for coming. Thank you for the support from everybody.
As we go through this, we're growing closer together as a community. When tragedies like this strike, you really realize how much you need each other.
Aloha everyone, I'm geologist Philip Ong, here with Mr. Dane DuPont of HawaiiTracker.com, bringing you guys another Kīlauea volcano update. Today, Thursday, March 24th, 2022. There's not been a whole lot of major change, everything has been minor, but the highlight of our minor changes on Kilauea have been this persistent lava fall, as you guys are seeing looping on the screen here. So we'll start off talking about that. We'll talk about the changes over the last week, viewing, the viewing's been like from the Kanakakoi Overlook, with some of the video from our viewers. And as usual, we'll go over the monitoring signals courtesy of the USGS Hawaiian Volcano Observatory, along with the webcam recaps and all of that. Our bonus this week is in line with the Volcano Watch, which is a recap of the March 2011 Halemaʻumaʻu eruption, a Pu'o'o, in a Pu'o'o era, a little bit west of Pu'o'o, that was a 4-day eruption. And augment that article with some video clips for you guys, so you guys can get a little more of the feel for what it was like during that time. So we'll, as usual, be discussing viewer questions in a way. So submit your questions in the chat, and you guys can have a discussion there, and collect some topics for us to discuss along the way as well. And let them know if you have any issues with our audio or with our video, as always with live social media platforms. All right, so unless you got anything to add, Dane, I'll jump into it here. And
no, go for it.
All right. it's been kind of a wet week on the volcano, and sort of down in the lowlands where Dane is, and up here in the volcano area as well. And so there's been a lot happening in the volcano, but a lot of that viewing's been obscured by, you see a lot of this fume blowing by, right? But I've kind of zoomed in here and looped and shown you guys. This is basically a daytime only clip for just the past 4 days, showing that lava falls. That's in that area of the archway that we highlighted last week. There was a little archway up in here. This area right in here. Oh, my not working. Let me get my pen working here. We had a little archway that was just temporary there that broke down. And it seems like the lava level now has basically stayed at a steady level where it's just pouring through that little gap at just the right rate where it's not filling up that pit. It seems to be, that pit seems to still drain out somewhere down to the bottom right here. But yeah, so it's filling it in and not, draining it away just at the right rate as it's filling in here. Let me get my brush because it's throwing me off here. I do not have my brush on here today, so I'm not sure why suddenly it's disappeared. And give me just a second to get that lined up here. It's supposed to be on one of these screens here somewhere.
Really is interesting how that whole thing has evolved, though. That whole lava cascades. Now it almost feels like or looks like a fountain, like an artificial one, where it stays in an equilibrium almost. It's moving in that direction. You know what I mean?
Yeah, exactly. Yeah. So we'll see. Yeah. So this is an interesting change that this, this kind of goes along with the other recent change that the pauses that we've had haven't shut off the circulation of the active lava surface like they used to before. I think the last time it shut off was a couple of weeks ago now. And there have been slowdowns that have lasted a few hours here and there. But even then, maybe only once a week or so, that we're seeing it's slowed down to that once or twice a week to that extent for a few hours. So some change with possibly the lava input coming in, where it's essentially in that equilibrium state, as you say, Dana, where it's basically just enough to be pouring over that edge and that persistent falls and pouring into this pit and then draining away. Here's what I wanted to draw. Here's my arrow. Very badly drawn arrow down here to the bottom right. So somewhere in there is where this thing drains away. So it was originally part of that main lake area, right? But as the lake has contracted in area, partly because it's cooling along the edges, but there's also a lot of bulging going on in the crater floor. I'll show you guys in a bit too. But the combination of those two things created this little division between this far southeast corner, we'll call it, yeah. And then that's evolved into this lava falls zone. So we're going to jump into it, right into the viewing this week.
There is one question though about this since we got this up.
Yeah.
Looking at that pit, is that the thickness of the crust? Does it go down? Is the crust thicker than that? The bottom of that pit that we're looking at.
So the crust is probably different thicknesses in different areas, and so the fact that we have the pit here in the first place, the bottom of the pit, that's probably one of the thinner areas of crust to the lava below there, and then also the bottom of this pit, larger active lake area over here. It seems like, right? Other areas like the island that's just off screen to the right over here, those are quite a bit higher and quite a bit thicker, right? And there's other areas that are bulging, and the outermost perimeters of the lake are slightly flatter, but the middle part has got all kinds of topography, depending on how much it's bulging and what lava features have formed there over time. So yeah, interesting question and interesting to think about. But yeah, that somewhat, it's not clear exactly how this recirculates back in, whether it's going more down. That is the thinnest area of crust there. What we're seeing as far as what's exposed is the variation of lava levels over the past few months. Here is how far up and down it's gone, and then below that we can't see.
Seems like it might be making the path that it has to drain a little bit more efficient as the time has passed over the last week or two.
It could be that, and it could be that the path of the lava coming into the system is more efficient, where the deflation-inflation events that were shutting it off all the way are no longer shutting it off all the way. It could be something like that, or it could be something where it's been bubbling into that westernmost pond and it's been connecting into the active lake, and that connection could possibly become deeper as well, where it could feed in from below more like, right? So those are all some possibilities there. Interesting to think about. But I wanted to show you guys a view. This is from our viewer 2 Pineapples. So mahalo, you guys. Took your last couple live streams here and just edited it down a little bit to give everyone an idea of what it's like from the overlook. So here's Kanekakoi overlook, zooming way into the lava lake area. So you can see the lava lake area is still only at 2.5% of that whole crusted lake floor, right? So zooming way in, there you can actually see in this bottom left right here, this is that pit. That lava fall is going into it, visible from public overlook. So you can't see the whole thing, just the top of that falls, but there it is. And behind it, that west vent cone complex. And then over there to the right was that west pond. So here, zooming into that top of the lava falls, you can see, depending on the day, this is rewound here back from Wednesday to Monday now. And the height of lava within this larger intermittent lake here, that's determining how much you're seeing flow into that pit. So you can actually see over here on the right, that west pond vent. A couple days ago, you can see it's quite a bit higher. So cascading from the upper vent right here down through this network of now a crusted over spillway with several skylights. We'll see that later in some of the thermals, and high lava level up here. And spattering, right? It's actually building a cone around this pond, turns out. So here, rewound back to just yesterday, and everyone's struggling with some rain coming and going there. So you see a lot of steam and a lot of these images here, and sometimes white out, and see there's some rainbows, and so these guys are dedicated coming out there and live streaming. So mahalo 2 Pineapples. That's the one view there of that lake. And here I'm going to turn to Epic Lava for a daytime version of that. Is really zoomed into the top of that lava fall. So the weather has been a bit of a challenge for viewers in the national park, but even still, there's been amazing stuff to see, as you can see, even these videos shot in on and off weather. All you guys at Epic Lava. Cool to see those pieces of that skin of lava breaking off, right? So thinking about, speaking of thicknesses of things, you can see the thickness of that crust on the main lake right here as these slabs that are darker that are breaking off and falling in. And that's the question that I was interested. That's another kind of thickness we can see here in this view. Let's keep moving on from there. So this is the S1 camera for the last week here, compiled by Dane. Mahalo, Dane. And so before we're zooming into this area right over here, right? So we can look at that once again, but to start off, we'll go with a wide view because there's other things happening in a field of view, including ooze-ups that are kind of out of sight below the crater wall over here. There's one you can see up here in the top right of the image that comes in on that northern part of the crater wall, while all this other stuff's going on with the filling and draining of the pit over here, right? And so as I zoom it in more, we can focus on this larger area. We see there was an overflow that occurred along the backside over to the west during that surge in lava. And as it looks back around here, you can see sometimes exposed that depth of that pit. And even when a lava level is dropping, it's not shutting off completely. It's still circulating within there. So it's still visibly showing the signs of pressure in a volcano with tilt, inflation, and deflation. But unlike before, when the deflation was stopping all the way, we saw it kind of pause there for 1 or 2 frames, and that's a few hours. It's not shutting off for 2 or 3 days at a time like it was before. So that's all great for viewing. More features to see over here. West Vent Cone Complex is still active. You can't see at this speed so much, but there's kind of spatter burst happening every few seconds from those cones, and sometimes a little more, sometimes a little less, and that's kind of the different areas that there are to see, right? Sides as well. So that's the S1 camera. Looking into the S1 just recently now here. I'll reload it. Hopefully it's not going to make it foggier here, but you can check on that's actually a better view. Check on the status of that lava falls. It seems to still be there. It seems to be filling that pit a little bit more down here in the bottom. It's not quite as tall, but as far as what you can see from the overlook, it's still charging over there, right? And this area over here must be putting out quite a bit of glow as well. Pretty cool to see. And then here in this view, you can see on the top left that upper pond, and now that crusted over spillway in between it right there. that. And then all these taller cones that seem to be growing and getting more pointed in the last few weeks here. All in the middle of all this fume left. And so that's a current view of the S1, and I'll throw in here this photograph released by the USGS overview of Kilauea. This is viewed from the east now, so the main active lava lake is this little pit right in here. Most of the cameras, like the S1 camera, are positioned somewhere likely in here. That S1 camera, that the KW and the thermal cameras are somewhere more in the north, or somewhere more in this direction over here, or above the vent, somewhere in there, perhaps. I don't know exactly. Maybe we should draw a much bigger zone than that, somewhere in that whole north zone over here. And then we also have that B1 camera we'll get to in a little while over here that's positioned on this down drop block in here. I imagine it's somewhere in an area over here. Somewhere in the zone over there. It looks down and at that closer part of the pit right in here. So the viewing area is not quite on here. It's just off to the left in this direction, but the view you get in is over here. And this cliff is what obscures much of this inner part of the crater floor. So that's all hidden from sight, something like that. But you can see essentially this whole back part of the crater all through here. And so if there's any ooze-ups in the side, that's also visible as well. And I'll see if I can pull that up for you guys as well. First little orientation, as we usually do, on the national park map here. This is the main caldera. There is that pit that has that crusted lava lake within it right here. Kīlauea Overlook is this one right over here. That's our main viewing area. We've noted at times in the past you could see things from Uwikahuna or Kīlauea Overlook. It seems that while the lava lake circulating within a pit doesn't cease during those lower pressure times in the volcano, during the deflationary cycles, we do seem to see less of those ooze-ups. You do see some little bit of trickling flows on the crater floor in the middle. But overall, it seems like it's not as consistent, the viewing from this north area, which is easier to get to, unfortunately, right? As far as from the east side, we've noted before, Waldron Ledge area, you can get a view from the east at the tops of those cones and that uppermost pond, but not so much that lower area or that falls. That's all still hidden behind that crater over here, and there's another crater floor edge right over there as well. Big cliffs. Say. All right, so one thing to note, right? Most of the views here from the south, and things aren't as crowded anymore, and people are doing a good job of timing things. Normally, you park here at Devastation Trail and walk this old crater rim drive paved road out until you get to a small little off the pavement overlook across the cinders to the overlook. But if this parking lot is full over here at Devastation Trail, then some people are forced to park at Puʻupuaʻi over here and walk the Devastation Trail across slightly further. So since this was released this week, I'm going to include another image of this area. It shows this little piece of that trail, along with Puʻupuaʻi, a cinder cone from 59 eruption of Kilauea and Kilauea crater right here itself. So that's the view we'll see next, is right through here, and there is the image released by the USGS as they were doing their flyover this week. Someone turned a camera towards Kilauea. The parking zone is not quite visible in the trees back over here, with the overlook into Kilauea pit over here to the north. But the trail goes through the woods and then snakes its way over this way towards the Devastation Trail parking lot. So here's all the cinder fallout. This is the other trail that goes down to down this way, all the way across Byron's Ledge here, and back up to the other side. So this trail is like reconnect and go back into the crater. This is a fantastic area if you're something cool sometime. But moving on, one last park media here to cover. This is a view of the overflight last week that occurred a week ago last Thursday. I've sped it up a little bit so we can have the benefit of a slightly smoother, faster helicopter right here. But you can see this is the main pit. The active lava area is a small area over here in the upper part of the black area. It's kind of a point right here. This is the edge of that ramp, the lava filling in and covered that down drop block area. So it's been encroaching up in this direction over here. And that's our overlook of the caldera itself. So as always, just to remind you guys, check the National Park website for their advisories and conditions and closures at any point in time when you come. And also they have this page showing the air quality. And since gas emissions from the volcano are still the biggest hazard, we're just making sure we cover that every time here. And everything is still in the green for Hawaiʻi Volcanoes National Park. The wind has been fairly strong today from the north-northeast, 13 miles an hour. So very strong gas plume moving away, but the winds have been kind of shifty recently. And so maybe it's not blowing to any one place, or it's not being dispersed to many places, but it could be blowing to one place down in the southwest area at higher intensity than usual. But looking at our VOG model, here's a VOG mapping project from Hawaii Manoa, University of Hawaii Manoa, with the SO2 input of 2,042 tons per day here. And it's showing the probability of reaching moderate levels of aerosols of VOG in the air right here. So mostly here in this Kau district of the Big Island of Hawaii, southernmost part of the largest island. So that's the SO4 particulates. There's SO2. I thought I could point out today, there's a couple of different charts here. We normally look at this red-tinged, red-toned graph with a percentage probability of exceedance. But they also have this concentration, which is more like a radar plot, right? With green, yellow, all the way up to purple is showing the highest concentrations as well. There are different ways to look at that. There's SO4, SO2, gas, and then the particles. You can see it actually gets higher concentrations in certain areas at certain times in that view. Still something to, be aware of, especially if you're driving through the area or down in Pahala region, South Point, Kīlauea, etc. Right. Here is the gas plot for the last month. Here is the SO2 emissions for the last month, tons per day on the left. We're going from 0 to 3,000. So as our full range here is essentially less than 2,500-ish, down to a few hundred-ish. And these couple points are taken during one of these lulls. During the last big lull, in fact, that we could see that complete stop for several days, multiple days there. Now there may be a second one in here. It's not, that didn't sample. It may be in here somewhere, something like that. But really, since then, there haven't been as big variations that have been noted. That might be for lack of sampling, but also we're still within that range. So not a whole lot of change there. Maybe we're just sampling the higher times, right? If you look at the in-place monitor at Sand Hill, you can see similar variation, maybe slightly higher concentrations in some directions. This is the area that I think that the wind is blowing in particularly intensely towards the recent hours here. So I think that's probably just local weather related there. And then scrolling up, here's our actual 1 month tilt. Microradians in the left, we're going from 3 to -3, so it's a 6 microradian range. It's not a huge amount, but that's been the recent tell of the volcano has been on this scale, right? So these larger downs and ups of the deflation and inflation cycles, pressure dropping in the volcano, increasing again, and these have been the pauses that were longer. We're noting earlier in the month, right? You can see a couple here, but really we had a short one and we've had another short one, and it hasn't really, even this one over here, it was still going down and came back up, only stopped for a few hours. So really this is the last perhaps larger slowdown we had here, and even that one was only for a few hours. So that could be the change in the pattern, and we also have this now very slowly rising background level of tilt here, right? Or it might have been slightly flat or slightly decreasing, hard to tell exactly what's going on there. But this tilt is what we have to proxy not only the pressure within the volcano, but also the lava lake depth now. So if I scroll up here to show you our 1 month lava depth plot, we have data up until a few weeks ago. And since then, it's been no data at all. And you can see before then, we were showing this range of lava levels dropping, corresponding to these big inflation events, and then rising again. There's a slight delay there, and et cetera, et cetera. So since we don't have the laser pointed anymore, we can't really tell what this difference may actually look like on that plot. Perhaps it might be slightly smaller drops, right? Smaller and shorter drops, rather than these long flat bottom things like this. I do think you'd still see this background rate coming up. So that's something we can look at in the updates as far as the numbers from the USGS, but that's the overall pattern we're seeing visually as well too. All right, so that's the 1 month. Here's the last week. Summit tilt, and depth is blank for the whole last week here. So we'll look at the F1 camera, and this is a compilation, another compilation that Dane has for the last week here, and restart this one here, showing that very small, short-lived slowdown in the crater floor early on in that week. And otherwise, later on in the week, coming to more recently, we're starting to see ooze-ups along the sides of the crater. But otherwise, you see that upper pond right there. You see activity at the West Fin complex. You see this overflow pond over here. And I'll do it again. I'll zoom in a little more to the lake area. You can see that initial overflow, the south, second pulse here. Very similar to what we've been documenting for the last few months, actually, right? Big difference being, this lake area is contracting. We have this one corner got pinched off. If we look here at this northern arm, it's looking like it's getting close to wanting to pinch itself off as well, right? So it may actually isolate another pit over here, and perhaps we'll see a second set of falls going this way. That would be hard to really see from anywhere, but that might be cool to see that develop another extension over here. I'm not sure what you'd call that, right? It's almost like a abandoned river segment in a way, right? It's an abandoned lake segment, abandoned lake extension, lake piece, lake part. So in any case, we'll see what happens there. That's the last week over the F1. Today, I just want to highlight once again how many ooze-ups are happening now, and maybe I should come back and note that we're at a higher point on the pressure right now compared to what we've seen in recent times, right here at the very, very far end. We're still climbing up, and that'll likely surge out a little bit. Then we'll see it drop down at some point again, and we'll see what's going on with that. That is what we're seeing there. So the ooze-ups, besides that F1 view, I wanted to show you guys just the last 24 hours of the B1 camera. There is that lake in the far end, but over here on the left side of the view, you can see this pre-dawn large breakout, like large ooze-out coming out over here. Let it play one more time again. And I want to just throw in one more thing up here, and that's going to be this video clip from Two Pineapples once again, and this is zoomed into that far edge of the crater on the north edge, another ooze-out flow, big sheets coming out, where see zoomed in further here, and you can see a whole bunch of different channels oozing out from the coast. It's a big flows when it ooze out from the sides, so really impressive to see. So for some other changes, we'll look at the V1 camera here. This is just one surge in the middle of the night on the 19th. One of those similar surges as we might come to expect here. The lava viewing might be good here tonight, tomorrow morning. If that surge continues, you can see a little bit more of this spattering speed time-lapse here from the west vent cones, which, due to that activity, keep growing taller and steeper, right? And you can see that 5 days ago, we still had this fully open pathway, perhaps a little bit of an arch starting to form, as we noted last week here at the very mouth of this spillway into the main lake. And this is what's been crusted over the last few days here. So let's take a look at that and look at that week-long animation here. And once again, we have all the spattering happening up here on the right part of the image. We see several of these overflows and then deflation as lava drains out from those flows downhill, right? It's kind of bulging at the center. It's almost like a doming crater floor. And so I will zoom in to this pit area for us to see. First thing to note is just the texture in a daytime view of this whole area right over here. You can see clearly here this is actually becoming a little spatter cone, spatter in the center cone, right? You see when it rewinds to a few days back before that surge, you see that it really doesn't exist. So it's kind of that whole pond rising up, overflowing its edges as well, and building up that whole edges, and then spattering as well. Right? See, here it's building back up again. And at the same time as it's doing that, you see these areas over here start to grow together and zip up as well. So that by the end of the sequence here, we only have quite a few skylights, maybe 4 or so, right? I know the camera is shaking around quite a bit, and this thing is so zoomed in, it's hard to really tell any relative change of the crater floor if things are rising or moving back and forth because of the windiness of the area. And when you're zoomed in that far, any little bit of wind can cause this amount of camera shake and movement. So you really can't say much from this scale of relative movement of things like growing up and down, apart from when you see like that cone like that grow up around the edge, right? And zipping up here. Pretty cool. This will be my time lapse of the week here. This process and this cone forming and this process of, right? So really have a upper perched pond and spilling through to a middle level intermittent lava lake and spilling through that distant lava falls now into that lowermost pit. All right, there is a V1 currently, and you see pretty full up close to the edge of this foreground here, but we don't really see it underneath this crusted over section. Separate pond, little flow coming down from those spatter cones. Keep it moving here. We'll take a break midway here for some discussion before we go into more of the nitty-gritty of the data. But I do want to finish it off here with this first part with the most recent thermal maps. Here's the wider view, visitor center, volcano house, Kanikakoi viewing areas over here, Uekahuna Overlook, former Jagger Museum is all over here. This is the area in that innermost pit still. There's still several depths of layers of pit that I would have to climb out of to get anywhere, which is why this poses no threat to people. Combined with the lack of signs of magma moving elsewhere underground, as USGS has been reporting for a while now. The red area, we'll zoom in on here, that's the active lava lake surface. So there it is, it continues to shrink, and we can actually see, if I zoom in a little bit more, there is our separate little pit right over there. Separate little lake, and a crusted over segment in between there. Northern extension that perhaps will become another one of these kind of deals, isolated. Let's see. And then 4 more islands over here. This is where the crust might be the thickest, is over some area over here, and back over here we had more of those original islets. But still you see there's some other lava flows coming up through that crust and from the boundary of that older crust and flowing across all this area as well. And the whole edge of the crater is all brighter colors from persistent ooze-ups. Same over here on this side. And that's the thermal views. And along with it, we have a new reference map. Similar kind of shapes here, but actually generalized rather than imaged from the. So there is that similar area. You can see the purple line here. Once again, that's the original crater floor after the 2020-21 lava flow there. And so you can see on the edge how much it's actually spread outwards, and that's a big amount of the area. So to date now we have 204 acres, 83 hectares as our full lava extent. Thickness up to 305 feet, 93 meters. So the surface is all the way up to 836 meters above sea level. We're still not anywhere near back where the lava lake was in 2018. Maybe halfway from where it collapsed back down. So it's come quite a bit, but it still has all this areas to flare out, as we've discussed over the months and years here, to fill up before it could actually do actually reach that same level. So it's got a long way to go. All this area here is what collapsed in 2018. Build to resume that former elevation. Okay, so one last thing we always do here is look at our eruption rates that we can get from our volumes, right? Volumes are up to 15.2 billion gallons, 15 billion gallons, or 57.7, 58 million cubic meters. It's growing amount. It doesn't seem to be slowing down really, but it's hard to really quantify. So we had our last flyover and map a couple weeks ago, and as usual, we can type in a new value and put it in. So here we are up here at around 58. At the far end of the red line, a red line is this current 2021 or 22 eruption. The blue line is eruption that occurred from 2020 to 21, which we've now exceeded in length. This is showing that we've gone on longer, and we've we've put out quite a bit more volume as well, right? That much more than that previous eruption so far. And not only that, we can see that given the slope of this line, that we've been doing that at a higher rate, really like ever since 1 month into each eruption, right? So ever since that first month passed, it's been a different story, a different rate of a more steady accumulation here. And this is interesting to consider when we talk about that more open pathway that USGS mentioned in Volcano Watch earlier this month. So we'll get back around to that as well, but so that's our total volume graph, and one more to show is our incremental volume. So it actually came out to around 3 cubic meters per second since the last graph, and this one, since the last point in this one, it's pretty hard for you guys to see in there. Right, these are all low values, but we've essentially been in the long-term rate of 4, 2, 3. We'll call that more than 1 cubic meter per second for a while. Scroll this graph back. We haven't ever dipped below 1 cubic meter per second. Whereas the blue line from the last eruption, you can see that by 2 months into the eruption, it had petered off quite a bit, and it took a while for it to shut all the way off. But it stayed pretty low at values below 1 for a long time before it actually shut off. So that said, there's no indication that this thing is stopping anytime soon. It can perhaps keep a more developing to be more open pathway with that long-term supply rate all coming into that crater to fill it up. Remember, unlike 2008 to 18, we have no outlet of pool and lava going onto the coastal plain. So all the lava that would have been ending up down in that area is all what's filling in the crater now with that same long-term eruption rate. It's all just piling in one place and getting thicker and thicker and thicker so you can see it. And I think the best way to visualize this, I put this together from this sequence that Dane gave me. And what I've done here is pulled out the last 2 months of this F1 camera and spit it into just like a second. And then I've rocked it forward and back just the last 2 months here. Right, so it looks like the volcano is actually breathing, but that's artificial because I've made it forward and back, right? But the point of doing this is you can see all these differences that have occurred and over the longer term, which are harder to tell here, right? So this area in the foreground all through here, this is all, you can see all the flashing around the perimeter. That's all the ooze-up flows that are coming in and laying pretty flat edges of the crater floor here, of this crusted crater floor. And this middle part has a darker area, as you can see, actually bulging up because it's likely that earlier, more buoyant crust, right? And you also see the series of cracks developing just inside this line right here, right? You see a series of cracks developing, and that's kind of the edge of that original plug of that 2020 to 21 crater floor right in there. So it's oozing out from anywhere in this area through here, anywhere outboard of that to the crater edge, repaving that whole zone, and everywhere else it's pushing it and bulging it upwards. Right, that's what's going on here. And as it's doing so, it's also flooding in. As this whole area is bulging, the ground is adjusting, of course, and some of these ooze-up flows from the edges are now starting to infringe and starting to overlap and onlap onto this area. So you're starting to have more and more repaving of the crater floor, except for these highest points that are islands, areas like this or back in here. Right, that's that original crater floor from before this most recent eruption. So that's all cool stuff to see. I wanted to point out a couple more things in detail. You can see right here the development of this embayment pit here on the southeast part of the island, right, over time from the F1. Cool to see that rocking, and you can see the one on the other side has gotten quite a bit skinnier too, right? It could have pinched off already, but it actually has gotten quite a bit skinnier. Interesting to see that. I'll scroll it down here too. There's a lot of things moving around, aren't there? But right around this west pond vent. You can see how it's moving. You can see the series of cracks just to the side of it right over here developing. And this is something noteworthy. I'm curious if this point will extend that west pond or open more outlets off in this direction, because that's right next to that upwelling of lava, and it's looking like it's getting pretty cracked through there. Or if it's actually able to move, and lava is passively filling those cracks and allowing it to essentially, I mean, it is erupting through there, but it's in a way where it's just pushing it up without a whole lot of resistance, where most of the flow comes out this direction still. And that's pretty cool to see. And then the last thing I'm going to focus in on here in this rocking sequence is the west vent itself. So a little bit hard to see in these darker areas, but the west vent cone here in the foreground, see it more clearly in the earlier part of the sequence, before it kind of gets buried, right? But you can see it's not moving up and down along with everything else. It seems to be more attached to this part of the crater wall somehow. So interesting to note that. But just outboard of there, you can see that there are a series of cones right over here that are on that rising crater floor, and those are the ones that have become taller, right? And dominate the view now in the middle of all that fume, and they're putting out all that spattering. Those are all coming up from this rising edge as well. So you can almost see that that whole edge is leaking, and it's leaking enough along this west vent area to create more of these spatter complex that's rising here in this zone right in here. So that's probably enough to go into for hopefully no one's had a seizure yet, so I'll move it on from here. All right, ready for our first break, Dane? And thank yous.
Yeah, sure. Let's get into that. So first, I want to thank everybody that tuned in today. We rely on viewers like you to, come in and on these live streams, but also to share it. We don't have an advertising budget or anything like that, so it relies on the likes and shares and comments and that kind of thing to help drive the YouTube algorithm. I know it gets tiring to hear about this on YouTube, but it's true, and it really does help. Those likes and subscribes and the share really goes a long way. We do have a $35 donation from our longtime supporter, Gary Bryant. He says, appreciate all that you guys do to prepare for these updates. Appreciate it, Gary. Appreciate the longtime support. We also have another supporter we want to recognize, Kilauea's Bar and Grill. They've been with us for a while now, too. They have two locations, one in Pahoa, one in Orchid Land, both in Puna. They have two different menus. If you're coming out to this side of the island, or you're looking to get out of the house and get a little bit of takeout or something like that, definitely check Kilauea's out. They got some traditional dishes with some unique local twists, and we appreciate their longtime support at Kilauea's Bar and Grill. All right. I think we can get into some questions. Don't have many right now. If anybody wants to get in some more questions, we can go ahead and try and throw them in. Christy asks, approximately how much has she risen in depth with this current eruption? So the difference between this eruption and depth and the previous one that it left off at.
Okay, so what I'll do is I'll pull up here the most recent USGS update and read it off for you guys to done that yet. I know you probably can't see it. I'll put it on the screen here. Lava on the surface this evening is an update today, by the way, for anyone headed out to the national park. But this morning's update here, we can see here, since the beginning of this eruption, September 29th, 2021, a crater floor has seen a total rise of 89 meters, 292 feet. That's right from the map as well, 89 meters. Didn't have time to do it today, but it's getting close to time to update that graphic, right? The graphic of the relative depth of the crater. We've used the Empire State before, or the Statue of Liberty, and various other things. Airplanes on there. It's about time to do some more size comparisons kind of thing. It's come up quite a ways, but it's flaring out now, and it's more impressive that it keeps coming up at a similar rate as before, even though it's flaring out more, right? That's really the amazing thing. So it's a pretty decent rate. It's still got a long way to go. But we're seeing it change quite a bit pretty fast, and that's pretty cool.
Richard asks, does the spattering intensify when the magma is rising or falling, or does it remain consistent as that happens?
It's hard to tell from these time lapses exactly, right? But it seems like from the videos that we've seen, the guys who've been live streaming and some of their videos submitted to Tracker and etc., that there is more spattering when you have those surges, right? More spattering, and you also have like lava coming out of the cones and it's feeding short flows from those areas too. So yeah, you have more sources of lava. The cones that are spattering might be spattering and issuing lava flows at the same time during those higher activity.
And that's true in general, yeah.
Yeah.
Okay. Richard asks, oh no, I already did that one. How much higher do you think that the pond is from the lake and the lake from the rest? It's from David on YouTube.
Yeah, that's a good question. That's hard to tell.
Right.
It hasn't
It's so
been
much.
reported.
It's hard to get a sense of scale down there, like something to base it off of.
Yeah, I mean we've heard before that little pond was like what was it, like 30 yards across, something like that.
Something like that.
So you would imagine that means that the the difference in height isn't as big as the size of that pond up there, right? As far as its width or its length, right? So I would guess it's probably a few yards, less than 10 yards, but it could be 5 yards of difference between the uppermost pond and that main intermittent lake. And in that other pit, that other one, that's where we've seen the change in variation in that main area during the deflation events has been up to, what was it, 30 feet, sometimes up to 45 feet. And I think I might have seen close to 60 at one point early on, but that other pit, it has a chance to be deeper, and that all depends on how much it can drain and all of that, right? Like, can it really drain down to that lowermost level, or how much can it actually drain, or is there some connection where it tries to equilibrate with that main pond? Yeah, that's all cool stuff to watch, and I don't have any better answer besides that little discussion right there.
Right. We have a $20 super chat from, I think, first-time donator Chris. Says, thank you so much for all the work you do to prepare or to keep us informed. And I appreciate the support. All right. So I think, there is one last question. Do you surf? From Mark.
Do I surf?
Yeah. Are you a surfer?
I enjoy surfing, but I'm very bad at it. So it's nice to be out in the water, and I enjoy, I don't know. I'm like kind of like a landform person, as everyone knows, right? I enjoy like looking at the shape of the land from the water.
Yeah.
On a board or on a boat or whatever, similar, right? But that's something that's easy to do. You can get on a board, and of course during whale season, you hear the whales, like being out there with the whales and the turtles. That's always been my, the actual catching of the wave and like trying to avoid other people. That's the part I'm not as good at, and so for everyone else's sake, I try to stay out of everyone else's way.
Yeah, I lost all my boards in the eruption, so I haven't gone surfing since, especially since all the spots that I liked are gone as well, right? So it went from surfing was cool to just zero interest. And, I go down to Pohiki and just look at, the beach break that exists nowadays. And it's just sad, right? Nobody's out there anymore. It has to be like a really good day with the right conditions to even get something rideable. That's just, depressing somewhat, in the terms of the surfing. We had so many good surf spots in Puna, and then we went down to just like nothing, like that eruption. So, yeah, we do have a $25 super chat from Eric. He says, keep up with the great work. Always enjoy the insights. Appreciate the support. All right. Well, I think that'll do it. Oh, and a $5 donation from Andre. No comment attached. Appreciate it, Andre.
Mahalo, Andre. Thank you guys. Thanks for all the support. And yeah, it means a lot to us. And yeah, if you can't donate, we encourage you to please like, subscribe, and share. And that goes a long way, as Dan says.
Yep.
So anything else before we jump into some more data, Dan, to wrap things up here, and then we'll do a little bit more of the Kamoa eruption at the end along with Volcano Watch.
Yeah, I think that's it for now. If anybody wants to get in some more questions, we'll do one more question and answer segment at the end.
Yeah, sounds good. Yeah, and actually, the data is we're gonna go fairly quick too. We'll spend more time on the Kamoa eruption here, but we'll just kind of round the bases as usual. So, geophysics. Here's a GPS at the summit. This is measuring the spreading across from north to south of the summit caldera, And it's been on a slow, steady rise, and not a whole lot of change there, and certainly nothing major in the short term, right? This is what led to the eruption recently, last September, and then initial stage eruption as it came back and relieved that buildup. And it's been a slow, steady rise since then, which has been slower at a lower rate here than previous to that, right? So interesting to tell that, it's still spreading, which you'd imagine means magma is still coming into the volcano, and not all the magma that comes into the volcano erupts at the top. It's probably filling areas underground and helping the volcano spread and then placing underground and swelling that whole network of pathways underground as well. But it's doing that mostly at the summit because we look down here at the rift zone at the pool GPS, and its north to south distance measurement has been contracting for a while throughout the whole eruption, with maybe some short-term changes, but nothing that's really notable there, right? You can see maybe it looks like it's slightly going up here in the last few data points, but that's happened before. There are even larger little deviations, and you can imagine some system where, like, if you have some block sliding down and it's gathering friction, it's going to kind of go faster, then stop and kind of bounce. And it can have some aberrations and not just be like a smooth. So all that's within the range of acceptable variation for the processes that we imagine are at play with the rift zone spreading there, and magma filling in a deep reservoir, but not really anywhere near the surface where it puts any threat to people. It's kind of the normal background of the volcano. As far as earthquakes, the 1 year view here, we're at that steady sin eruption, during eruption average, same eruption there, and we have this kind of background of earthquakes underneath the summit, which is still a curiosity to me here. We're still curious if this is going to be an effect, and maybe as we consider the changes occurring and whether the volcano is having a more open conduit, and magma's coming in or not, like, this is just one of these variables that is hard to integrate since we know so little about what's happening that deep under the volcano there. But that is something that we imagine after some time, maybe it has some effect. Not visible in earthquakes at least, but maybe so in the continued eruption at that same rate. So that's the 1 year view. In the 1 month view, you can see that there are shorter term variations. Some days are lower, some days are higher. It goes down, it goes up. This is all within a range of 70 to 10 or so, let's call it, which is all kind of normal background at this point. If to go up to the hundreds or thousands, then it's something else going on, right? So earthquakes per day is our measure here. So everything's normal there as well. Not a whole lot really noteworthy to talk about. Here's our 1 week earthquakes. Here are a few shallow ones, and still some between a Mauna Loa adjustment zone here, and then here's a south flank, and some deep ones occurring even within the last week in that conduit area, deep conduit area, and one extra deep one over here in a deep rift, or even below the deep rift. This is way down in the mantle here. Very deep earthquake. It just happens to be underneath that part of the rift. Nothing to do with the rift, in fact, that depth. So there's a cross-sectional view. A few of these deeper ones under the summit. This is the Pahala cluster, the deep Pahala cluster, the surface adjustment above it with no connection in between. No known threat of eruption there. And everything else is looking normal. There's that deep one under the south flank area. Okay, as far as rates, it's been so low, it's hard to tell any meaningful variation in rates there, right? And here over the last month, you see a little bit more of that long-term pattern, but still not very heavy, even over a month as far as earthquakes at the summit. You see a few here in this Nāmākani Paio area, right here, which is something that we've learned was a response to magma coming into the magma system of the volcano during the last build up to the last eruption. So we imagine that's another sign of magma reservoir still filling, but it's doing so without having to do any major quaking. It's kind of just able to bulge and spread and bulge and spread and bulge and spread, all up here and then not reaching it. So there has been one interesting earthquake that elicited a response from the USGS here, magnitude 4.5 beneath the northwest flank of Mauna Kea. This was Sunday, March 20th, 7:30 a.m. It was felt not just on our island, but also statewide, they say. And essentially, depth of 14 miles, 23 kilometers is likely due to settling structural adjustment of the Earth's crust due to the heavy load of Mauna Kea. right? That's the official response there. This flank has experienced 9 earthquakes greater than magnitude 4 within the past 60 years. So not a huge amount, but it's not unprecedented there as well. Right? That area typically has over 30 earthquakes at depths greater than 20 kilometers every year. Just smaller ones usually. So it's a little bit bigger than usual, but still normal and nothing to worry about. Nothing's happening in Mauna Kea. In case there's any hype going around, I haven't even looked, but if there is, there's nothing happening in Mauna Kea. No effect on Mauna Loa or Kilauea at this time either. All right, so moving on from that, we'll show you guys the earthquake map. Here's the earthquake map. There's that Mauna Kea earthquake with some aftershocks at 4.5 right there. Still having 3.5s down here in the Pahala, Deep Pahala zone, 3.3 down there as well. 3.1, so only 3 magnitude 3s this last week, maybe slightly down. But otherwise, it's pretty background looking map for those guys that follow this with us over the months and years here. Not a whole lot of anything noteworthy to talk about here. So we'll just move right through that. And just mention here, this is a volcano watch I've been referring to from March 3rd that discussed the rise and fall of the lava level, which is shown here in blue in both plots from 2018 to 2022. And here I'll zoom it in, blowing it up for you guys here. But you can see that before there was a very little delay between the green line and the blue line, a lava level and a tilt at the summit in Lava Lake 2018 and 19. And we're seeing a little bit of a lag occurring here at each of these resumptions of inflation to the actual return of lava, right? So this is what we're theorizing. USGS theorizing here that perhaps there's like some partial blockage, right? So that when it's repressurizing, it's got to clear that blockage and then it can burst through it. And so it's not quite an open pathway, but maybe transitioning towards becoming open because it's starting to have that pattern where it's everything is mirrored. It's just not mirrored exactly one-to-one yet. So that's where all that discussion is coming from. If you guys haven't missed that before, just wanted to pull that back up. To demonstrate this is a video from back in 2012 and 13, but this is a 2-year time lapse of the lava level within that pit of 2008 to 18, showing variations over 2 years of how lava level would in the long term rise, but also have lots of these fluctuations. It's never sitting still. It's like, it's bobbing up and down and bobbing up and down, and up one week, down the next week, and up and down and up and down and higher and higher and higher, and then spreading and changing shape. But that's just to give you an example of that last era of the Summit Lava Lake, how that open system, open pressure was manifested in that short-term variation week to week and day to day, month to month. And by the end here, you see very high lava level in 2013. It's kind of led up to the 2015 overflow of the lava lake. It's the first time that happened there. But at the very beginning of the sequence, you can actually have some very drastic changes here. So the lava level is actually quite high. At the very beginning of the sequence, it drops way down. I should stop it right there. Yeah. And so there are some differences here from 2008 to 18 to now, and I've mentioned it before. There's no pool pathway open, and that means that there is less network in the rift zone for magma to drain to, perhaps, right? As we also saw in 2018. So to kind of show this a little bit better, let's pull up here that first part of that video here and put the tilt alongside it. This is another USGS video. And here you see the lava level coming up and then dropping way down along with a tilt. So this was a drop of 50 microradians or so, and then you can see the slow rise back up over the subsequent months towards the end of the year here. You can see the short deflation-inflation cycle is still occurring all through there, with all that background on a long-term rise of the lava lake, right? So that's kind of what the kind of thing that we have as context for what's happening now. We're not seeing this steep a rise, but maybe it's starting to rise a little bit. So you can see sometimes you have smaller variations, sometimes larger variations, and those are the dynamics that we're tracking at present here. The analog being of this 2008 to 18 eruption of what's happening today. Similar kind of things happening today. So that big drop, this big tilt drop, right, that's the 2011 Kīlauea eruption. That's the Volcano Watch topic this week. It's already been posted in HawaiiTracker.com if you guys want to check it out, the article. I'm not going to read it all, but I will note the highlights here. And this one is essentially a little different in the sense where it's got a few more pictures as it's put forth as a somewhat of a photo essay, right? This week's Volcano Watch is a photo essay, highlights the episode and some of the data collection that was done with that eruption. So Kamomoa was in the middle of that 35-year long Pu'o'o era. And this was a 4-day-long eruption. And we'll go through here first, the sequence, right? So the sequence was an intrusion first that occurred westbound of Pu'o'o, in between the summit and Pu'o'o. And that interruption diversion of lava from the Pu'o'o pathway caused Pu'o'o's floor to collapse here. And you can see a big ash cloud rising from the crater while there's still bits of lava left behind from that draining of it. Here's Pu'o'o on the top left of this image right up here. And you can see this is uprift towards back to the summit. And you see this series of cracks right through here is one area, and then here is another area of this Kamomoa fissure that lasted 4 days in between these zones. So like a surge of pressure came through, burst through the zone that was weak ahead of Pu'o'o, right? You can see these old existing cracks are here in a view as well. And they will play a part in the story coming up too. So in the first few days, activity shifted around the two fissure systems with vents repeatedly starting and stopping. On March 8th, it focused on the two opposite ends, right? So kind of focused to here and here. And it was over on March 9th, 2011. Here you can see HVO scientists mapping and measuring ground cracks, developing cracks. And not only were developing there, you could actually, they reported standing there and watching them get wider and wider and wider. We'll see the video of the one that got the widest, and then lava started coming out of it not long afterwards. But here you can see volcanic gas collection using FTIR, a Fourier Transfer Infrared Spectrometer. And they use this to measure the gas coming out. And so the peak value was 11,000 tons per day with an average rate of 8,500 tons per day. So not anywhere, what was that, like 40 times less than we saw in 2018. 20 times less. Quite a bit less, but still huge amounts compared to what we were seeing before that time, which was essentially an order of 1,000 to 2,000 tons per day from the summit and some both. Right, another photo in this essay of a geologist collecting lava from the Kamomoa. See that the fountains from the fissure were decently high, maybe not quite 100 feet, but ballpark-ish, 60 feet, somewhere upwards of that. And they were feeding lava flows at their bases that were flowing down throughout this terrain. That's in the foreground. I see this lighter colored stuff. This is all the cinder. That's the spray of the high fountains of Pu'o'o from 83 to 84. So a very different looking ground. It doesn't have bare lava on it. The lava's underneath all that cinder. It just can't, it just makes it look different. So see some vegetation growing up. So the lava samples collected indicated that the eruption either pushed out or mixed with a body of cooler magma that had been stored in a rift. And as it continued, the composition began to resemble of those previously erupted at Pu'o'o as a fresher lava flushed through the system, just like we saw in the beginning of the eruption. So that's a little small chapter here. The history of the Pu'o'o zone, and that, of course, was a March anniversary that we just passed here. And I thought that we could augment this for you guys by showing some of the videos that were part of this sequence as well. So this video shot by the geologist Tim Orr. You can hear the sound of the jetting gas. Keep your eye here in the foreground. You see that chunk of rock as it fall in. So that crack is actively widening, and Tim's standing here straddling this crack. So when he sees that crack widen and that chunk of rock fall in right there, he looks in there and there's lava coming up, and he decides it's not the best position to be in. So he positions and He's filming, but you can see further up over here. This is that same crack that lava's just beginning to come out of when eruption first begins. So when fissures begin, they don't start off shooting in the air thousands of feet. They kind of just start bubbling up a little bit. Like a crack widens, it starts bubbling, steaming first, then bubbling up, and then it starts shooting up a few meters, a few yards, making some small flows. Then eventually, as it evolves, it progresses from there, and we'll show you guys videos of that. So this next one taken from the helicopter. There's that fissure line right there. Big flows pouring into another neighboring crack, and this lava is essentially going to cool back down in that crack in the earth and won't ever erupt again. See how long that fissure system originally was, all the way across, and this is before it settled at both ends of that fissure. Right, here's another helicopter in view right in there. Our buddy Ikaika in it. Later found out. Momo eruption. Epic 4-day eruption there. In the middle of the national park, nowhere near any houses or people. They did close some parts of the road and things like that, but it didn't really have any effect on people, to be honest here. So another video from the ground. A few days into it, maybe 2 days into it, 2 to 3 days into it, you can see those growing fountains, building spatter cones on the side, right? Some big explosive bursts, big globs of lava, right? And as a zoom out comes here, you can see it's feeding big flows. There's one wrapping around. This is that same view as we just saw in that, where's the volcano watch image here? Right here where they're measuring the gas right here. And perhaps the next day or the day before the end of the eruption right here at these highest bursts of lava. You can see above these small hia trees. And this is when it was focused just in one spot and not strung out across the entire fissure line. Into it. So that's going to wrap it up here. That's the last of the Kamomoa footage, I believe. And we can have a little bit more discussion, Dane, and wrap it up here.
We got a couple questions here. Two Pineapples asks, with the time lapse of the bowl, you can see the opening of the with the opening of the bowl, can you see the opening of the magma chamber a bit? What could be the approximate diameter of the magma chamber? So I think there's a little bit of two questions there.
Time lapse of the bowl. I'm not sure which time lapse you guys are talking about.
Probably that bottom cascade, that one that you opened with.
Okay. Let's find that one.
That would be my guess. It's hard to know at this point.
So yeah, so that's the one that opened with. But I thought perhaps that thermal one that was rocking back and forth. Find that one again. Maybe in this one, huh? Because there's this whole question. Maybe I'll. It's a good question, but we'll spin off of it a little bit also here. We've discussed in the past this whole distinction between magma and lava, as whether the material is above ground or not, right? And so we have everything emplacing beneath this bulging crust in the middle here. And really, it could be called magma before it's leaking onto the surface. And in that case, you have an upper magma chamber forming within this pit here, right? And in that case, if that's the one we're talking about as far as magma chamber, diameter of this pit is, I want to say, like a mile-ish, something like that.
Something like that. Ballpark. Right,
yeah, I know you guys know that the viewing area is a mile away, right? So it's maybe not exactly, but it's ballpark that, yeah. Maybe 3/4 of a mile might be more accurate there. So that uppermost chamber is something like that, right? Now we haven't pulled up the that diagram from Poland in a while, and maybe that would help as well to throw up here at this point in time. It's been a while in review. Let me dig that out of the vault here. Throw this on here. Okay. This is a diagram that's from professional paper. I forget which one that is now. USGS professional paper by Mike Poland and others, showing what's thought to be the one model of this overall structure of the inner part of the volcano. So we have here depth in kilometers beneath the surface. So 0 is not sea level, it's actually the surface of the volcano. This was all put together before the 2018 events and collapse, and so we have like a collapse that went down like this since before that, and it's been refilling, that kind of thing there. So I've been discussing, you know, what I might propose, someone might call the upper magma chamber forming within that pit, all right within here. That's the size of it. But maybe it's 3/4 of a mile or half a mile more in a core if you know add some give for the cooling edges of that pit kind of thing, right? The one below that over here, this is what we normally call the upper chamber or the Halemaʻumaʻu chamber, right? That one's thought to be down, you know, between half mile, 3/4 of a mile down. There's a lot of question marks as far as the exact position, dimensions, and the size of this thing, right? But it's, you know, it's just one idea of it here. That one might have a diameter of, yeah, probably similar thing, you know, maybe half mile-ish, something like that. And then there's a deeper one below that, the South Caldera chamber. That's the main reservoir, right? You know, I mean, the main large pocket of it. Maybe it's a pocket or network, but you know, the whole rift zone is a big area, a big volume. It's a big reservoir as well. There's lots of other reservoirs besides this, but you know, this is what you'd normally consider traditionally as your main magma chamber, right? But it's more like the center of the reservoir, we'll call it, the heart of the system, perhaps, right? And that is thought to go down between this 2.5 kilometers and 5 kilometers down. So that one while it might be more elongate, that one might have more like a mile or more diameter there, right? That's the different scales of them going down. So hope that answered your question, you guys. Mahalo for all the live streams you guys are putting out. That really helps, and I'm sure I'll run into you guys out in Overlook one of these days.
All right, so move on to the next one. Bob asks about the hotspot. He says, if the Pacific Plate is moving northwesterly, why is a source of lava staying in place? Is it static versus plate moving? Is it a difference in time frames, like geologic time versus human time?
So the way I like to answer this question usually, let's see if since I'm in my cross-section area here, I don't know if I have the right one here, but this cross-section we have on the screen here, all this volcanic pile, as we call it, it's all within the crust of the Earth here, right? So there's like mostly solid rock, and within that solid rock there are these established pathways that the magma has established pathways through, okay? All of that's riding above. Let's see. I gotta find a proper cross section here. I gotta have one here somewhere.
It's always trying to find the thing that you need, like at the time.
It's not exactly the right one, right? But this has got some of the some of the things I wanted. Lithosphere is area of solid rock up here, right? So this is that area that all that pathway is going through here, right? So the hotspot that's coming up is probably getting deflected and bent over as the lithosphere, as this tectonic plate over top of it is moving across to the northwest. So this is essentially northwest is this way, right? So the hotspot coming up is getting dragged across. So there's like a long time where it's heating the bottom of that crust, but it has to find ways to poke through that solid slab that's moving together coherently, right? So while the hotspot is moving, or the plate's moving, the hotspot's moving, there's kind of two things going on. One is that there's like a longer zone of hotspot. It's not like a one point right here and then that's it, right? That's kind of one part of it. And the other part is that besides that, there's pathways through the crust as well that get carried along. So as this crust moves along, the pathway gets carried along intact, right? And that's why it kind of keeps going up to the same place, and you have that more of the gravity spreading in the volcanoes from the top, south flank movement and rift zones and all of that as it occurs like that. Hopefully I explained that.
Yeah, I think that'll work
a little bit, so got some piece of that. But yeah, thanks for that question. That was a good discussion there.
We'll end with this
once in a while. Yeah,
definitely. And we do have a stream highlight video compilation of talking about the hotspot. If you do want to check that out, it goes for a couple hours, huh?
Yeah, we put a lot into that. Yeah, and it's been like a year or something, so that there's actually a whole bunch of new research since then.
Right.
That we could be add on to and making another chapter someday, but leave it be for now.
Right. A lot of work on that one. All right. So last question for today is from Joseph. He says, how long do you think it would take to get back to the pre-collapse levels at the current eruption rate? I don't think it can. At the current eruption rate, I don't think it can. Like, run that thing as long as you want.
Yeah, I would have to actually project it out at a current rate, right? I haven't done this in a while, but we did do this early on with the last eruption, and the answer, even at high rates, was years, like 2.5 years, right? So,
and at the current rate, I'm like, we'll all be dead by the time it gets back then, up to that level. The current eruption rate.
Well, the current eruption rate is like what, like 4 cubic meters per second, we'll say, or 3
but we're
cubic
draining
meters per
a lot
second.
too, like that draining effect. It's not like we're just net adding every time, with that. There's some loss back into the system.
Well, so that that value of 3 is the time averaged from 3 weeks ago. So whatever is going on between there, like, starting and stopping. I mean, actually peaking higher than 3 and dropping back down and stopping sometimes, but that's the time average is actually 3. So that's, I mean, I think it actually is like that value of Pu'o'o was, it ranged between 2 and 4, maybe as high as 6 or 8 sometimes, right? But that, it's single digits. And that's where we are. I think that's totally believable. It's the long-term supply rate, we think, is in that ballpark too. And it could just be leaking out straight up like that. And if it does that, I don't think it's going to be forever, right? I think it'll be maybe 1.5 years, 2 years-ish, something like that. Because the previous level is not the same as the whole caldera full and spilling over either, which is something else we've calculated too, right? Which it would take, before 2018, it wasn't tall enough to spill out of that inner pit and out into the main caldera either. It was in an inset crater then as well. So, right, that just a couple of reminders on all the different considerations we're throwing in there.
Well, we will see. I mean, the thing is will this eruption continue that long?
Yeah,
that's the real question.
That's always been it, right? It's not so much, the eruption rate is this or that, but like how long will it last, right? And so that's really it. Well, if it lasts 10 years, then yeah, absolutely, it'll get there. But if it stops every few months and restarts and stops every few months and restarts, then that's going to slow things down as well.
And this thing's been kind of weird in that I remember we were like 2 months ago talking about how the last this pause could be the last type of thing with the way it was going, and instead it kind of got rid of the pauses and it made them less clear on what is a pause.
Yeah, I mean, even then we noted that there was there was a range of possibilities that existed, and right, that was like just one that the point of view existed that was stated in the Volcano Awareness Month program, that the geologists would not be surprised if it was the last one, right? But then we also, the same 10% of the kind of arguments of like, look, it looks like an open system already, right? Ignoring those slight little lags, it was more open than we've seen it before. So,
and it seems to be continuing in that direction of open.
It's going more open. Yeah, it continues in a more open direction, I think.
Yeah,
what I see.
That's what it appears like. All right, well, that will do it for the questions and answer segment today. Appreciate everybody that trimmed in. Make sure to like, subscribe, maybe throw a comment on the video after we go off the air. That apparently really helps with the YouTube algorithm. But until next time, we will be back next Thursday at 5 p.m. Hawaii Standard Time, unless something goes off, and then we will go live with an update on that.
Yeah, for sure. So thank you guys once again. Please like, share, subscribe, as always. And until next week, unless something else happens more exciting, from HawaiiTracker.com, he's Dan DuPont. I'm Philip Ong. Aloha, everyone.